Hello, Brandon Clayton, the Algebra Guy here. As you can see on your screen, we are talking about Pemdas. Now, if you're at this lesson, you probably already heard of Pemdas and are familiar with the order of operations. Parentheses, exponents, multiplication, division, addition, and subtraction. That's the order we always need to remember as we're working expressions or solving an equation. So let's get to it. So by the end of this lesson, you'll be able to solve a problem like this, no problem. Just remembering PEMDAS and breaking it down appropriately. So let's get to our questions. What is PEMDAS and how do I use it? How do I simplify expressions using the order of operations? So just a quick reminder, because we have talked about this before, but I want to go over some more problems since we've added to our repertoire of abilities with decimals and fractions. We're going to continue that. So PEMDAS is your parentheses, exponents, multiplication, division, addition, and subtraction. So we're always going to go PEMDAS, and we're going to make sure we go left to right. If we're ever in a situation where they're both the same, like multiplication and division, the one you do first is the one furthest to the left, and then you move to the right. Same thing for addition and subtraction. If that's all you have left, you go left to right. Let's do it. All right, so looking at this problem, we'll start with our P. Do we have parentheses? Yes. Can we simplify something in the parentheses? Absolutely. 18.3 minus 21. Well, 18 is smaller than 21, so I know it's going to be a negative number. But I can still go ahead and put the 21 first and just remember the final product is going to be negative, because the difference between these two numbers are still going to be the same. So subtracting, we get 7. Actually, I'm going to go ahead and put my negative because 18 is smaller than 21, so I know it's going to be negative. 7 minus 3 is 4. Another thing, I line up my decimals when I'm adding and subtracting and go straight up and down like this. We got bar 1 here, 11, this is a 3, and so we get negative 3.4. So rewriting this, I have a negative 3.4. We don't have exponents, but we do have multiplication and division. In this case, it's multiplication, so let's divide. Yeah. So I'm sorry, I said let's divide. Let's multiply. So 3.4 times 7. Again, there's no need to put the negative here because it may be confusing. It'll look like a minus sign, but we will put it here to remember that we're multiplying a minus or a negative times a positive, which is a negative. So let's go ahead and do the math. 7 times 4 is 28. 7 times 3 is 21, plus 2 is 23. And when I multiply decimals, I count the total number of decimal places between those two factors. So I only have one movement here, so we're going to just put it here because we just moved it one spot. So our final answer, negative 23.8. So that's what you get after doing all that work there, using PEMDAS appropriately. Simplify this expression. Again, PEMDAS says do the parentheses first, so let's do that. Let's not even worry about the 2/3 right now. Let's do 8.3 minus 3.8. It's going to be 7, 13, 5. 7 minus 3 is 4. And there we go. So let's rewrite this, showing that we've simplified the parentheses to 4.5. How do you do that? How do we multiply this thing here? 2/3 times 4.5. So can we do it this way? 4.5 times 2/3. No, that's not going to work. These numbers both need to be in the same form. They either both need to be fractions or both need to be decimals. So this is not going to work. So let's erase that. Which one do you want to change it to? I would encourage you to pause it at this point and work it the way you want to work it and check your answer with what I get. Now I'm going to work it both ways. I'm going to translate this into a fraction first, and then I'll do a decimal. It'll probably be easier to do it as actually, now that I look at it, the best way is to make it a fraction, because 2/3 is a repeating decimal. And how do you multiply a repeating decimal? You're going to have to cut it off at some point, right? And when you cut that thing off, it's not going to give you a perfect answer. So you're approximating at this point. And we don't want approximations when we're doing simplifications of this sort. We just want an exact answer. And so the best thing you want to keep it in, especially as we get into algebra, keep it in fractions and get away from the decimals as much as you can. So how do we write 4.5 as a decimal? Well, if we remember when we were naming decimal, this is the same thing as 4 and 0.5 tenths. 5 tenths. Well, so that's the same thing as 4 and 5 tenths. Well, I want to change this to a mixed number in preparation for multiplying it to 2/3. So to change a mixed number to a improper fraction, I'm going to multiply 4 times 10 is 40 plus 5 is 45. There. So what did we do at this point? Well, we simply translated or transformed, converted is actually a better word, 4.5 to a fraction, an improper fraction to be specific. Why? So that I can now do the correct operation on it without much problem. So now we know how to do that. Just multiply the numerator times the denominator. And if you do that, you're going to get 90 over 30. And that becomes easy, right? Because 10 divided by 10, these zeros going to divide out if you divide by 10. And we're left with 9 over 3. 9 divided by 3 is just 3. Now here's a bonus. I want to show you something. 2/3 times 45 over 10. Let's start that again. So we could have got here a little bit easier, or just should I say differently, by breaking these top numbers into smaller factors. Like we say that's 2 right here, and breaking this 45 into, what is the two numbers that give me 45? 5 times 9. So let's say 5 times 9. So we got 5 times, instead of 9, let's put 3 times 3. Break it into its prime numbers. Now we've done this before, but I wanted to show you the value of doing it this way and possibly time saving. 3 times 10, 3 times, instead of 10, we'll put 5 times 2. And look what happens when you do it this way. And this is not, it worked out pretty nicely here, but sometimes you have a funky looking number. It's a big number and you're like, man, if I multiply this number's going to get so big. Well, don't multiply and make it a big number. Just break it down into small factors and you can start to cancel out. 2 over 2 is 1. 3 over 3 is 1. 5 over 5 is 1. So all we have left is, yep, you guessed it, 3. So that's another method you can use in order to tackle those types of problems. All right, let's do Pemdas on this one. Don't be discouraged that all that writing, just take one bite at a time. I always tell my students, don't be discouraged at the big problem, just like a piece of cake you love. You don't get discouraged when you get a big piece of cake on your plate. You don't say, oh my goodness, how am I going to eat all this? You pick up your fork and you take one bite, little bite at a time. Hopefully a little bite, but you take it very carefully and slowly. Well, we're going to do the same thing to this problem. We're not going to look at this whole problem and say, oh my goodness, this is just too much. It's just, no, one piece at a time. First, let's start with our Pemdas, parentheses. Do we have parentheses? We do, but there's nothing in there to solve. It's not added to anything. It's just parentheses around it to show that we're squaring everything inside. Do we have exponents? Yep, right here. So we need to take care of that exponent. So what is 0.1 squared? Well, 0.1 times 0.1. That's what that equals. So 0.1 squared is the same thing as 0.1 times 0.1. So let's multiply that, 0.1 times 0.1. And it seems like a silly operation because you just want to say, oh, it's 0.1. But let's look at it. 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. And I add up everything. It's 1 and 0 and 0. Now here's where it may surprise you. Because we're multiplying, we need to add the total number of decimal spaces. In this case, it's going to be 2, so we go 1, 2. So our actual answer for that part right here is actually 0.01. Now, if you would have just thought of that, you would have thought, oh, 1 times 1 is going to give you 0.1. But it's actually 0.01. So we did our exponents. Now what's next? Our multiplication and division. And do we have those? Yep, right here. And we have multiplication here. So let's go with those. What's 6 divided by 0.6? We're going to leave this space here for work, and I would encourage you to do that when you're working your problems in math. It's so important that we stay organized and have some kind of methodology when working our problems. Get your own system together. So as you can see, when I'm working my actual problem, I keep everything over here somewhat neat. But over here, I have my workspace in which I can start working the problems. I keep it neat. That way I can come back to it and check my data in case I did something wrong. Now, in this case, I'm going to erase because I need room. I want to erase it now, but I will get to the point where I erase it. All right, so, but I do need to do 6 divided by 0.6. 6 divided by 0.6. So 6 divided by 0.6. How do I do that? Well, remembering again from another lesson, when you're dividing fractions, this divisor needs to be a whole number. To make that a whole number, we need to move the decimal one place. In essence, we're multiplying it by 10. So we multiply this by 10 and this by 10, moving this one space. So now my new problem looks like this. We have a 0 here, and this becomes 60 divided by 6. How did we get that? Because originally 0.6 divided by 0.6. So all we did was multiply the top and bottom. I'm gonna erase this Pemdas for a second. So we just multiplied this top times 10 and the bottom times 10. We multiplied it enough by 10s to get it to be a whole number. And that's how we got our 6 and our, what did I do? 0.6, and this should be 6. So this wasn't there. That was just 6. So that gave me 60 and 6. And that's pretty easy to do right there. So 60 goes in here once. It's going to get a 0. 6 divided by 6 is just 10. You can do that in your head. So here's one of those. And I did this one first. Why? Because it's the furthest left, even though I have both multiplication and division. Now 0.2 times 4. I'm going to make a line, create some separation here, and we're going to do 0.2 times 4. 4 times 2 is 8. 4 times 0 is 0. And I move one space, so that's going to be 0.8. So this is 0.8. And it looks like I worked everything. Now I have to go back and do the addition and subtraction. So now what we're looking at is 6 plus 0.8 minus 0.01. Which one do we do first? Again, the one that's furthest left. We go left to right. We don't do 0.8 minus 0.01 and then come back and do 6. We start from 6 plus 0.8 minus 0.01. So what is that going to give us? 6 plus 0.8. 0.8 plus 6. I should have put that in different order. Gives us 6.8. What about 6.8 minus 0.01? 0.01. So let me separate that, make sure that's clear. So let's keep that 6.8. But this time we're going to do 6.8 minus 0, not 0 like that. I'm going to keep my decimals lined up because we're adding and subtracting. We always do that. I'm going to bring down, I'm going to create a 0 there for a placeholder as I'm subtracting. And this, intuitively, you can know we're just taking 1 penny away from 80 cents. So I know my answer is going to be 6.79. So I do 7, 10, 9, 7 there, 6. So you can do the math, but just think about it. Sometimes it helps. I'm taking 1 penny away from this 80 cents, $6.80. So 6.79 is the answer you get. All right, what about this guy here? Starting with PEMDAS, do we have parentheses? No, we don't have anything in parentheses that has an operation. We just have these separated by parentheses. Exponents we do have, so let's do that one. How do you square a fraction? How do you square a fraction? To square a fraction, we're simply going to square the numerator and then square the denominator. 1 times 1, so let's write that out so you can see it. This is the same thing as 1 times 1 and 10 times 10, or 1 squared and 10 squared. So that square goes to both the top and bottom. And we can see easily now that it's going to be 1 over 100. Or as a decimal point, 0.01, because that's like a penny, 1/100th of a dollar. We want to convert that to a decimal because we see these others are in decimal, so that's going to make it easier for us later. 0.01 plus, and we're not going to add 3.5 because PEMDAS says after your exponent we go to multiplication and division, so we're going to multiply these two. 3.5 times 0.9. 5 is 45. 9 times 3 is 27, plus 4 is 31. 0 times 5 is 0. 0 there. We got 5, 1, and 3. Since we're multiplying, I'm going to add up these decimal places for both factors, and it looks like it's 1 here and 1 here, so that's a total of 2. So I'm going to go to my final answer, start at the end, and go 1, 2. So I now know my final answer for these two will be 3.15. Now I simply add these two together, 3.15, lining up the decimals because we're adding 0.01. And again, we're just adding a penny to it. So that gives us 16. Did we answer our question? What is PEMDAS and how is it useful? How do I simplify expressions using the order of operations? So we talked about PEMDAS. We talked about how to convert fractions to decimals, decimals to fractions, and that we need them all in the same form to really work them through. Guys, I hope you found that helpful. Again, my name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.